So I'll talk today about my work on consensual and privacy-preserving sharing of multi-subject and interdependent data. And this is joint work with collaborators from both EPFL and UNIL. So we all know that today individuals share a lot of data online, right? We share photos and videos on dedicated platforms or on social networks where we also share location. And recently we also share our genomic data on platforms such as OpenSNP. And as soon as this data is shared, it is obviously up for scrutiny by either the service provider or sometimes even third parties like we've seen before. But the problem that we focus on in our work is that other individuals can often be affected by such data. So notably, this can happen when the uploader is not the sole owner of the data, which is, for example, the case of photos where multiple people appear or other people appear, or when the data has consequences in terms of privacy for other individuals simply based on due to correlations. So for example, from your location data, from your friend's location data, your location too could be inferred, again, like we've seen before, or from your relative's genomic data, your genomic data could be inferred. So this is what falls under the umbrella of multi-subject and interdependent data, and this is what we focus on. Of course, this comes with a lot of privacy for the users, but the first question that we should actually ask is that of awareness. Are you aware of the data that's available about you? So how stuff works today is that anyone can post anything online about you. You might not know, your friends find it, your family finds it, a job recruiter finds it, and you only find out about it when you've already been embarrassed or even worse, discriminated based on this data. And there is this special and very sensitive family of photos which has received a lot of attention in the media recently, and these are revenge pornography photos, which are explicit images shared by a partner online. And this can actually cause a lot of problems for the service providers as well, if they allow it, because they can be sued for it. And this happened recently with Facebook, for example, who just settled a case of court with a woman from, I believe, Northern Ireland, who sued the company just exactly for this reason. And of course, this creates a precedent. And they have, the company has actually tried to discourage at least revenge pornography, and recently also tries to fight it. For example, they deployed a prototype in Australia recently, which essentially said, hey users, if you are worried about a particular photo being published by someone on Facebook, just send it to us, we'll make sure that never happens. Of course, this requires quite a big privacy leap of faith from the user, so in terms of privacy, they can do better, I think. So to put some numbers on the problem, we also performed our own survey, in which on Amazon Mechanical Turf, roughly 300 participants, in which we found that a bit more than 10% of them said they were, in fact, victims of discrimination and prejudice based on content shared online. But more interestingly, almost 67% of these said this happened because of content shared by other people. And also we found that roughly 4% of the participants reporting having been victims of revenge pornography at least once in the past. There is some good news as well. There are elements out there which are encouraging. For example, the fact that identifying or tagging people, at least in the case of photos, can be automated. So for example, we see that Facebook has this tag suggestion feature, which what it does, essentially anytime you upload a photo, they automatically identify the persons in it and they suggest you to tag them. Also, the fact that companies start to accept the notion of consent is very encouraging. So for example, Facebook also offers their users the possibility to request that content published by someone else be removed. So I actually tried it. I wasn't happy with the post. I filled in the online form. I had to send a photo ID as a proof, wait about a week, and they took it off. Of course, the problem with this is that it assumes there is user awareness, which is not necessarily the case. It assumes it's not too late, right? 1 week can be a lot. Your friends might already see it. And it ignores one other possible adversary, which is the service provider itself, right? What about my privacy with respect to Facebook? And you can imagine there's a much more privacy invasive photo out there. Another example, Pornhub, which is one of the largest adult entertainment websites out there, recently started to use AI automation to identify the people in their videos. And they're doing this to provide a bit better search and categorization. But they too have been trying to fight revenge porn. They haven't yet quite connected the dots as far as I'm aware. But even if they do, the same question remains, what about the service provider? So what we wanted to do in this work was to combine such elements that already exist, like face recognition, with the right cryptographic tools to provide a better solution in terms of privacy for the users. So specifically, we wanted to provide them with a system which would automatically and privately detect who is affected by some data that is about to be published and give them the option to say something about it before this happens. Of course, this comes with many challenges, starting with identity claim, moving on to detecting who is affected by some data in a private way, which essentially means we want to not really look at the data, but know who it's related to. We also wanted to privately contact these people, which means we didn't really want to know who we're contacting, but give them enough information to make an informed decision. And finally, we had to collect and enforce these potentially conflicting consent decisions. And most of these steps are actually highly data dependent. So we wanted our model to have some key features. We wanted, obviously, it to be effective with respect to the goal I just mentioned, to provide privacy through anonymity and unlinkability, and again, privacy with respect to other users of the system, but also to the service providers. We obviously wanted it to be usable and transparent and be robust against malicious users. So in terms of the adversary, we consider the users are malicious, but the service providers we consider to be honest but curious. And for an overview, we have the following components. We have a content management service, or CMS, which can typically be any user-generated content site, such as Flickr or Pornhub, YouTube, etc. We have an identity management service, or IMS, which is typically the service that manages the user identities and can provide re-identification services of users based on a particular content. And the role of this can be typically played by Facebook in practice or by government agencies. And both of these have naturally user components that they can interact with to publish or to review consent requests. So what we proposed in the paper was a prototype that works for photos, which is called ConsenShare, and I'll briefly explain here how it works. Let's say we have a user, Alice, that just took this photo on her phone and she wants to upload it on Flickr. What the application would do is first detect the faces in the photo. Alice would be prompted which faces she wants to appear in the published photo. Those faces would be blacked out in the published photo, which is called the background image. And if there are any other faces that will not be asked for consent, these are blurred out. As soon as someone gives consent, their face would be appended in the published photo. Now, of course, there are a lot of open design choices here, right? Why black out or blur? Why use a square and not a circle? What kind of obfuscation to use? Face obfuscation or full body obfuscation? How to make user decisions? We just allow for manual decisions, which can be cumbersome, or do we allow for automation by machine learning or by policies? There are many open questions here, and these are essentially design choices. They can be integrated, but they are left configurable for a reason, because they actually can vary from CMS to CMS, notably by regulation. So I'll describe one possible solution next. And for this, what we consider first is user registration. So at registration, a user must provide a webcam photo of themselves. The IMS will then process the photo to identify from the user's face the feature vector, which essentially consists of, or face representation it is also called, which essentially is a numerical representation of their face, such as the distance between their eyes. And this has the nice property that it's different for every single instance of a face, but it's close enough for faces belonging to the same person, which allows for re-identification. And to go into more detail, in that scenario where Alice wants to upload a photo from her phone, the first thing that would happen is that photo would be processed locally, the background image would be extracted, and for all the faces that must grant consent, their face representation would also be extracted. The background photo would be sent to the IMS first, which would validate that there are no real persons in it, and to the CMS, which, upon verification, would then publish this image. Now, there are several steps that would happen for each face that must grant consent. Their face representation would first be sent in an encrypted way to the CMS. This would forward it to the IMS, which can decrypt it and look up the best match and its contact information. Let's say this is Bob, who can then create a key pair and directly communicate to the CMS to receive an encrypted version of his face and look up the full photo with his face and decide if he wants to grant consent or not. And if he decides to do so, he will give his key to the CMS, which can decrypt Bob's face then and append it to the photo. Of course, upon validation of the entire protocol, just to make sure there are no malicious messages there. So in more detail, in terms of privacy analysis, what does the CMS see? It sees the background image, which is insensitive, and it sees encrypted faces and encrypted face vectors of Bob, which means it cannot link encrypted faces to user identities. And this is because of that property I mentioned of face vectors, which differ in every single photo, and which means also that their encrypted versions would differ a lot. The IMS would only see the face vectors, which doesn't provide enough information to link their identities to photo, and this is mostly because the CMS acts as a mixing network. And a consenter only sees the background image and his own face, not those of other users. So this means we provide user anonymity and unlinkability, and we're also robust against malicious users. We believe there are a number of incentives to encourage adoption of such a system. Notably for the CMSs, there would be an incentive to follow new trends or regulation, avoid those lawsuits I mentioned, and maintain good reputation, and even a possibility to increase user base. And similarly for the IMS, there's also the possibility of an increased user base, and business-to-business arrangements with the different CMSs using their services. Of course, for the users, there's the incentive of raised awareness and control over their data in a usable and transparent way. And for this, we also prompted our participants about their potential interest in ConsenShare. And a bit under, roughly 85% of them said that they would find ConsenShare useful or very useful. And while there are some losses in utility, obviously, more than 50% said that they would still use it. And almost 60% said they would use it with machine learning automation, and a significant number said they would use it with various policies. So for example, 55% said they would use it with a policy that would automatically deny geotagged photos. So in terms of the technical feasibility of our solution, we implemented a prototype using 128-bit security for each operation. We implemented it in Python with open source libraries for the crypto operations and for the face recognition. And we evaluated naturally with a data set of real photos that users publish on Flickr. So specifically, we constructed a random sample of roughly 17,000 photos from the Yahoo's YFCC 100 million photos, and we also performed some statistics on it. We found one which is particularly interesting for ConsenShare, which is, for example, the fact that more than 99% of photos users publish actually have 6 or less faces in them. And we computed the efficiency of the prototype in terms of per photo CPU and bandwidth requirements for all the entities involved. And we essentially found this to be reasonable. So to conclude, what we propose in ConsenShare is a system that preserves the main features of existing CMS and provides privacy guarantees to with respect to the other users and to the service providers, and with negligible overhead. We intend to extend this to include more human interaction aspects at the design level, and to perform a usability study for a fully integrated prototype. And I don't have time to cover this, but I do invite you to read in the paper how this can be extended to other data types. And I want to end with what I consider to be the most important message, and this is mostly directed to the service providers out there, which is that the ingredients are there. Good recipes are there as well. This is hopefully one of them. It's time you consider privacy at the very core of the design of the products you suggest. And if anyone wants to learn more about this project, you can follow the link below. Thanks for your attention, and I'm happy to answer questions.
All right, we have time for many questions. Maybe I can begin with a couple. Great talk. At a high level, it seems like there's a very interesting tension between protecting individual privacy versus also protecting individuals' ability to sort of take pictures in the public domain and have control over publishing that information. So I'm wondering if you can comment on that aspect a bit.
Yeah, so of course there's always a trade-off between freedom of speech and individual privacy, right? What we focus here was really the regular user who should have a say in what happens about them, which is why we provide the intermediary solution of just blurring, have that freedom of speech without having to go through the consent, and then you just blur all faces, kind of like Google Street does with their maps. So yes, there is a tension there, but we believe this to be a reasonable solution. Middle one.
Hi, Matt Hofeld from Qualcomm. I noticed that you de-identify people by removing their faces, but human beings are really good at identifying other human beings from body shape, and tattoos particularly have been of note of late. Do you envision expanding beyond just face de-anonymization in future versions?
Yes, they're also good at identifying people based on the color of their t-shirt, their body posture, and they don't even have to look at the camera in the picture. Yes, as I mentioned, there is a new body of work out there which is not our own, but which does exactly body identification and recognition, so which could essentially be used to blur out or obfuscate in a different way the full body of the person to avoid just that.
Question at the back?
Hi, Greg Cusack, University of Colorado Boulder. So I was just wondering if you could talk a little bit about your false positive and false negative rates. If your classifier is blurring out images that are misclassified, so they're either classified as the wrong person, or your classifier sees something that's not a person and thinks it's a person, how does your system deal with that scenario?
Yeah, that's a great question. We actually address it in the paper. So in terms of, that's actually not our input, right? It's the face recognition part, which will get better and better. But still, you might have these cases, right? And so in the case where a false positive occurs, so there's there is some content that's identified as a face but isn't, actually what would happen is you as an uploader that wants to upload it would never select that for consent, right? Or it would be blurred out. And if someone else is asked for consent, and it's not really appearing in the photo, then we actually offer the possibility to report that to the IMS, which is the identity management, which can obviously use that to refine the models.
Great, thank you.
Right, I think we have time for one more question as the next speaker sets up. Maybe I can take this one. I wonder if there are challenges in terms of validating the ownership of a face. So what prevents me, for example, from creating an account in say, with a photo that belongs to you, and then using that to compromise an individual's privacy?
Yeah, actually, that's part of the identity claim change. I didn't go into much detail there, but what could happen is essentially that's why we request a webcam authentication, so that the photo is realistic. But there is body of work that shows how to prevent a user to just use a photo of a photo in front of the webcam. So what could happen there is we can use something like Airbnb uses, for example. There could be some human validation of a photo ID or something like that, just to make sure that no fake accounts can be created.
All right, thank you. Let's thank the speaker once again.